Okay, so questions concerning what we have done this morning? No questions. So this morning we saw mainly conditionals evaluation, this if clause, and then something about cycles. We saw two main ways to make cycles, so loops, looping over lists by using the for keyword, or the other possibility to use the while construct. There is something more to say about these possibilities. Here, the different way to write a for loop. We already yesterday already have an example of this one, this type. In this case, for instance, I have two arrays of two lists, in fact, of length 4, and I want to create a list C. It contains the summation of the two list element y. So I want a list C which contains the sum of 10 plus 2, 20 plus 3, 30 plus 4, 40 plus 5. And in NumPy this is immediate. In Python this is not immediate. We have to write a for loop. And we use it by using the zip function. We can do it by using the zip function that we already encountered yesterday. So this is something that you already see. Now you have this zip function that acts on the two lists A and B and couples the elements so that you have a zip function working A and B will return couples, tuples of numbers 10 and 2, 20 and 3, 30 and 4, and 40 and 5. And the results of this coupling will be put in a cycle way into the variable IA and IB. So for IA and IB in zip AB, at each cycle, IA will contain the first position, the number 10. The first cycle will contain the number 10, and IB will contain the number 2. In the second cycle, IA will be 20, and the IB will be 3, and so on, up to the end of the list. And the summation of the two numbers in each cycle will be appended to the array to the list C. So at the end of the day, you have the results of the evaluation, which is 12, 23, 34, and 45. So this is nothing new with respect to what you see already yesterday and this morning. So nothing new, but you can also do in a different way. With this construct, which is very useful and used a lot of time, which has a specific name, it is called list comprehension. List comprehension, something like that. You see, I define the C list. Yes, so the variable C equal to, and I use the square brackets to indicate that what should be contained inside the square bracket should be a list. But instead of using a list, of putting directly a list inside, I put an expression that will return a list. So I have our element of the list C will contain IA plus IB. Each element of the list will contain IA plus IB for each IA and IB in the zip AB. So this way to work produce the same output, the same result, the same list C as before. But instead of writing a construct like this, one that requires initializing the list C and then go through all the steps of the cycle, of the for cycle, it is done in one solution using this list comprehension. You just have to put care in this. There is just a thing to note. For instance, I want to do something very Similar, I use a array A, list A, 10, 20, 30, 40. Then I write a list comprehension, very simple, but I don't use here the square bracket, I use the parentheses. This construct will contain every number which is contained in the list A. So for IA, for any IA in A. So this D should contain 10, 20, 30, and 40. But it will not immediately, because I use this parenthesis instead of the square bracket. And in fact, if I run this cell, I got D, but D is of the class generator. We already encountered generator yesterday. We encounter zip. Zip is a generator. We encounter range, which is used to generate a generator. In this case, by using parentheses in this list comprehension, we create a generator D, not the list that you want. Now, if we want the list, we have to type list D, or before list D, I can run, for instance, a command like this one, next D, and you see as D is a generator, and when you apply the function next, you will get, at the first time that you write the next D function, the first element generated by D, which is the value 10. If I apply it again, you will get the second element, and so on up to the end. Or you use list D and you get all the list that you want. So two different ways of generating a list by using list comprehension. If you enclose your expression inside square brackets, you directly generate the list. If you use the same expression in parentheses, you will not generate immediately the list. You will generate the generator of the list. We will produce the generator of the list, in this case the D, and then you can get the list by writing list D, list of the function list with argument the generator of the list. So this list comprehension is very widely used, so you have to learn it. It's better that you learn it. It will come very useful. It allows you to write code which is very compact instead of using a more elaborate for loop or while loop. Is that clear? I hope so. Just delete this few lines. Okay. Nice.
May I ask a question?
Yeah.
So I don't know why, if I write next D, and then I obtain 10, 20, then I do list D and I just obtain 30 and 40, but I don't understand why I don't
Because
get
if you note, you didn't note, but before I write list D, I again run this cell.
Okay.
I generated the D from the beginning, so I deleted all the information that the interpreter had already. Because if you start to write to typing next D, then the counter of the generator will proceed.
Okay.
So you have to turn back and then go into to the original cell to generate again the generator from the beginning.
Okay, thanks. Thank you.
Jupyter Notebook are very useful, used for didactic reasons, but you have to pay attention, because if you click on to run on some cell down the notebook, you will change the state of everything. And so if you go back to the previous cell, the state of the notebook is changing. So can make some jokes, and you have to pay attention. Okay, that's all for what concerned the cycle. And then I switch to another argument, which is the I/O, the input/output, which is very, very important. Generally, you elaborate data. You don't write data inside your arrays manually, as I did now, or by using some function like range or rearrange or link space that allow you to write element or number in a certain way. Generally, you have to read data from files, and you have to also to save data on files. And, and so there are several methods of working with files in Python and in NumPy. Now I have a folder here which is called data files. This folder is in the same directory where the notebooks are written and run. And this is important to be known now. You will see. The first things I do, the simple thing I do now is using NumPy to read data in files. In files, so several types. So I run the cell import numpy np as usual. Then I have this cell containing data equal to np, so numpy dot loadtxt. Loadtxt is a numpy function that read data files from the folder, from the disk of your system, and as argument of the function, there is the file name comprising the path. So I want a file which is called files.txt, and then it is under the folder data files. So I go into the data files, and I search for files.txt here. So I open it with an editor. You see that this file contains two columns of floating numbers, floating point numbers, and I want to read it. By the way, the loadtxt function accepts other, even other arguments, optional argument, but now it is not the case to have any other argument. You will see that later, maybe. So all the content of the files.txt will be saved in a variable which is called data. Now I run the, the cell, and you see print data, print this object here, which is a two-dimensional array containing a number of rows and the number of columns. The number of rows is exactly the number of rows that you have in the data file, the number of rows that you have here. And each rows contain two columns. So this is a two-dimensional array with two columns and a number of rows. If you want, you can also type print the shape of this data file, this data, so shape. And you see as a 9,2 shape, so 9 rows and 2 columns. Then I want to save my data in this way. I want that all the data which are in the first column, so -1, 0, 1, 2, -2, I want those numbers saved in a variable, which is an NumPy array, x. I will call x. And all the data in the second column, I want them is saved in the variable, which is y, another NumPy arrays. So I use slicing to do that. Use slicing, as we saw yesterday. I write data, square bracket, and now I select the elements by using the slicing. So a column in the first position, which indicate uh, all of the data which are contained um, in the first column, and the first column because I use a 0 here. So the first column has index 0, and the y data are all of the data, so a column here, which are contained in the second column, which is the column with index 1. Then I can print x and y, and what I get is this one. First column, it is written by row, but anyway, they are the data which are contained in the first column, and the second column is this the y is written as a row, but in fact it is a one-dimensional array containing all the data that I add in the second column. Okay, so np-load.txt is the most easy way to loading data in a in a structure, in some array in your system. Now, data is still preserved. Now, data is this the two-dimensional array. If I type data 0, I get back the first row. Data 0 is the first element of these two-dimensional arrays. So data 0 as the first rows contains the number, it contains the array -1, 1, this is the first one. Okay, and if I type data 3, for instance, I get another array, 2, 4, which is this one. So the row with index 3, 0, 1, 2, 3, I land is on this array having element 2 and 4. So I can select rows by using this way. Now, suppose that you see that our array is written this way, this file is written this way, -1 dot and nothing, -1 nothing, and so on. And I want to rewrite this data in another file, which I will call myx.out, but with a different format. I would like to format my data so that they are written this way. The first column is a floating point number, F notation, with 3 decimal digits. And the second column, the y data, should be written with an exponential format with 2 digits. And the function to do that is writing numpy function save txt, and as the argument I put the file name comprising the path, which is data file, and the name of the files, the data that I want to save, so the array data, and the format. The format is specified by writing the keyword fmt. fmt equal to and then a string containing the format of the numbers. Then I run the cell. Then I go on my folder and I find myx.out, which is the name of the output file that I want. I open it, and you see that now it is written this way. So floating point numbers before, but the first x column is written with 3 digits, as I requested, and the second column y is written with the exponential notation with 2 digits for each floating point number, as I requested. Okay, that's the easiest way, but this is not the most flexible way to reading files. So I read a file using load.txt, but this is not the most flexible way to reading file. Maybe that files contain row different type. Some rows can contain strings. Some other rows can contain numbers. Maybe that the row have not the same length, so the number of columns is different for each row. And so the load.txt function cannot be used. This is used for reading homogeneous files, so definite number of rows all of the same type and the same number of columns for each rows. But imagine that you have a complicated file uh, containing data written in different way. Now I can show you an example if I find it immediately. Some of the, for instance, imagine that your input file, so the file that you have to read, is something like this one. In this case, contain rows preceded by an hash character that I want will be treated by my program as a comment. Then I have rows, which are there are some keyword followed by other strings, rows which contains a keyword followed by numbers. So this file cannot be read at all by an NumPy txt function. I should use something else. And in this case, I can use the Python way. I can read in the file by using the Python way, which is more general, but a little bit more complicated. So the first things I do is to use this open function followed by arguments. Open function is a function that takes as argument my data files, the names of the data file comprising the path, and the number of the possible option. In this case, I use the option R. Option R means that I want to open this file in reading mode. So if I put the R here, then I can only read data from my files, and I cannot write. If I try to write something on the file, I get an error because I open the file with the R option. If I want to write the files, to write something on the files, I should use the W keyword here. Or if I want to read and possibly write, I could write RW, and the file could be read and written at the same time. The open function will open a channel, a communication channel between our interpreter, Python interpreter, our system, and the file that I have on the disk. And this channel, the handle for the channel, will be saved in a variable, in an object, which I call f. I could call it as I want. I call f. F stands for file. And, okay, I run already it. Anyway, this type of f, I can print the type of f, is this particular type is called an IO, a text IO wrapper with name, which is this complete name, file name comprising the path in mode R, and so on. So this is the type of, it is not really, it is directly F. So if I want the type of F, I have to write type of F. Okay, it is a class, it is an instance of a class. This class is this io.text IO wrapper. Then I can read all my data in the file by this syntax. I'm using this syntax. I use f, my object, dot read. So f.read is a method. The read is a method of the instance f of the class defined here. Then I close the file. Close is another method that I can apply on f. So the open will open the file, f will close it. I can write, I can see what's happened. All my data read from the files are transferred in this list, or list of lists, maybe list data. So f.read will read everything which is contained in the file and save it in data. Then I print here the type of data and the data themselves. And the problem is that, you see, type of data is class, is a class as str. So the data are not numbers. And what I read from the file, that was number, this number here, just floating point numbers, in fact, are not number, but they are string. Even if when I print data with using the function print, I see my uh, apparently list of floating point number as before, as more or less as was happened before when I used the load.txt function on Pi. But the point is they are not data, not floating point numbers, they are strings. Have a look at the first element of data. We expect a first element of data should be minus 1, 1. But it is not. This is a space. This is not an empty string. This is a string containing a space. That's strange. And that's, if really I want to see what is this data variable without using the print, I write data without using print, and you see what is data. Data is a unique string containing our numbers in a string representation, contains spaces, and contains the strange character n, /n, \n. This \n are new line character, carry age return character, the one that are inserted whenever you go to a new line when you write a file. For instance, you have -1 dot, some spaces, 1 dot, then you go to the second line, so you insert here a carry age return, and you go to the second line, then you have 0 dot, some spaces, 0 dot, and then another carry age return. And exactly you see here the same thing. You have -1 dot, some spaces, 1 dot, carry age return, that you have a 0 dot, and so on. So quite complicated strings that you can't use as it is. So if you expect to have number from a file, you don't get numbers. You get a string containing some formatting option. In particular, in this case, option for going to next the line when you go through the string. By the way, these carry age return n are those that produce this structure when you print the data variable, the data string, by using the print function, because the print function goes through the string and try to print everything along the string and interpret all these characters which are preceded by backslash, following their meaning. So \n in a string tells the print function to go to another line. So the print function will start to print this -1 dot, some space, and then 1, then encounter this \n, go to a new line, and then print the second line, and so on up to the end. Now, what we should do with a string like that in order to convert two columns of number that we may wish to have at the end? Well, we can apply a certain number of methods that a string, as a class string, as an instance of the class string, has. For instance, there is the method split. Split is a function, is a method that accepts an argument. In this case, I don't use any argument, so I choose the default argument, which is nothing, just. That take this string and split in several parts, assuming that a space in the string is a character. The space is a character that can be used to split the string. So I write data.split, parentheses with nothing inside, and I will get a string as a list of strings separated by where each string is identified, the end of each string is identified by the fact that there are spaces inside. So I can run this, and then I put a result in this variable, which is data split. I run this cell, and I print the data split array. So you see what I get. All the white, all the character, the space character being removed, and what is the result? I got the same string where I got this separate strings containing all the numbers I have in the files, -1, 1, 0, 0, 1, 1, and so on. Now I have the size of this data split, which is the number of strings I have in this file. I didn't print now, I can print size here. 18, so I have 18 strings here inside. Then I can convert all the strings in floating point numbers, and I can use it. I can use for this the float function that will convert our strings, our list of strings. And I use a list comprehension here. So what I do, I write square brackets, and inside the square brackets, I write this construct, which is a function applied to data split dd. What will do this data split dd will get all the elements which are contained in this list, indexed by the integer number dd that will go across the list range sites. Sites is 18. So data split dd will be a number that I will strip. I will also use this function strip that eliminates any possible other space character that could be present in our list, and also eliminate, if any, backslash. To be clear, if I here write the data split without the print, don't know what happened exactly. Data split. Okay, you see this data split contains our list, but written in this way, in a column, not in a row, as the print function does, because there are probably hidden some carriage return characters. Those n/n characters which were present in the string. I want to eliminate them. I want to eliminate this /n, and I do this by using the method strip. So I will take any element of this list. I will eliminate, if present, I will remove the /n for every dd in range site. So I do this, I print it, and that's the result. So every strings, which seems to be a number, will be really converted in floating point number and written in this list, which I call data array. Is it clear till now? So I use a list comprehension in this case. This is the list comprehension. Okay, now I want to separate X data, so the data from the first column, data from the second column. I can do this by using slicing. So from the element, the first element of the list till the last element of the list, the end of the list, separated by 2. We do step 2. You see that I have -1 is an element of the X of the first column. 1 is an element of the second column. 0 is an element of the first column. Or the other 0 is element of the second column. So the elements in this list are organized in this way. First, you have an element of the first column, of the original first column, and in the second position, you have the element of the second column, and so on for all the other elements of the list. So if I start from the beginning of the list and I select element using step 2, I will select the element -1, first column, the element 0, first column, the element 1, first column, and so on. Whereas if I start from the first, the element with position with index 1 in my list, I will select the element 1.0, which is from the second column, this other one, because even here I use the step 2, which is an element of y of the second column, and so on for all the other numbers here. So by using slicing, I'm separating the element of my array into different list, into different array, one-dimensional array, one which is x, one which is x, and the other which is y. So this is the result. This is exactly the same result that we obtained by using the numpy loadtxt function. So much more operation to do in this case, with respect to more extraction and taking care of a lot of things to do with respect to the numpy loadtxt function, but it is much more general. So when you have files containing every sort of data, you can always read those files by using this method of Python. Okay, here there's another way to read the file, same files, using Python, so not using NumPy. In this way. So first I define my channel f in the same way. So I open the files and I assign an handle which I will store in the variable f. Then I define a line. A line is simple, a list, which is an empty list at the beginning. Then I set a flag, which is a variable, which is a Boolean variable, which I initially set to the value true. Then I start a loop. A loop with the while construct. So I use the while loop. In this way, while flag is true, do the following operation. So this while loop will go on forever unless at some point the flag will be turned to false. In this case, the while cycle will terminate. But until the flag is true, the system reads line by line data from your file. So instead of using read, f.read, parentheses, to read all the file in a single block, I read the file line by line by using the function readLine. So start from the beginning, file line will contain, at the first cycle, will contain the first line contained in the file. And in this case, I will strip the carriage return by using strip. And I split my lines by using the space character. So in single one operation, I will split my line and will eliminate carriage return. So at the first place, what I will get will be -1 dot and 1 dot, and this is the first line of the file. In fact, -1 dot and 1 dot, which is the first line of the file, already divided in two pieces because there is the split. And the result will be saved in the variable file line. Then I'll check if not file line. Now this says if file line was a line which was present in the file, uh, this test will be true. Sorry, will be false, not file line. So file line will be true if there is a line in the file that can be read. Otherwise, if there is no file, there is no line in the file that cannot be read, so no new lines, file line will be false and not file line will be true. So the our loop will go on until it finds lines in the files. So when we will arrive here to the -416, then we'll try to read the next line, but there is no next line here. So the return of the readline function, the readline method, will be false. If file line will be false, then not file line will be true, and it means that if something is true, then execute what is written here. Otherwise, just append file line to the list line which is defined at the beginning. Okay, so I run the file, the cell, and at very soon it ended because it arrived at the to execute what is the content of this instruction here. So it read the red line, read the file line by line. At some point, arrived to the end of the file. We'll execute print end of file, so it will print end of files, and we'll put flag equal to false. In case it finds the end of the file, it will put the variable flag to false, and the while loop will be terminated. The while loop will go on until flag is true, but now flag is set to false, so the while loop will terminate. If you forget to put flag equal false here, then the while loop will go on forever. And you have to stop manually your program because otherwise you get maybe you can have a crash of the program. So while loop, as I told you before this morning, take care that there is some instruction in your program that would terminate when some condition is realized, would terminate the infinite while loop. In this case, this instruction is flag equal to false. Okay. And this is what we get. Line is updated, is upgraded every time, every line which is read from the flag, from the while flag. Start from a string from the list which is empty, then append the first line, then append the second line, third line, so on. But all these line will be stripped and splitted. So each line now, each file line, is a list of two members because of the split. And so each file line is a list. And you are appending to your line lists. So at the end of the day, at the end of the cycle, you have a list of lists. Now you want your structure X and Y as before, as we are already done here. And we can write these other lines of codes. So start to look how many rows you have in your file. How many rows is given by the length of line. Line is a list of lists. Each list is a row in your file. And so the length is the number of lists that you have in the array line, the list line. So row will define the number of elements of this list. And the elements are lists. So 1, 2, 3, 4, 5, 6, 7, 8, 9. lists, which are corresponding to the 9 rows of the file. Then, how many columns you have in the file? Then take the line 0, take the element with index 0, or any other element, in fact, in your file. Take anyway here, in this example, the element with index 0 of the line array, of the line list, and this element is the list composed by -1 and 1, so 2 elements. This is the number of columns. So I have the number of rows and the number of columns. Then I set data list to an empty list. Then I start 2 for-cycle nested. A for-cycle that will go on rows for the file and a for-cycle that will go on column. So 2 for-cycle nested. Look at the indentation. I write the for-cycle here on the variable IR. It will be from 0 to range rows, so all the number, the integer number up to row. And inside for each row, you have a read. So you have some elaboration on the columns. So for another cycle, on the number of columns that you have in your structure. So for IC in range call. Range call in this case will be 2. So in range call will give you a list of 2 integers, 0 and 1. And in case of the row, this range row will give you a list of integer from 0 to 9. Then in the most inner cycle, this cycle under the column, for the column, just write data append. So append to the list data that initialized to the empty list. This thing float line IR IC. So line IR IC, you see I write this two couple of square brackets. The first one selects the first square bracket with an index inside, select the row. And when you select the row, inside the row, you select the column position by IC. So at the beginning, both IR and IC will be 0. So the first element that will be selected from our line will be -1. The second cycle on IC will select 0 for IR, and IC will be upgraded to 1, and so you will get the second element here. Then terminate the cycle on IC on the column for the first row. So the row is upgraded. IR will change its value to 1. And IC again will go from 0 to 1. So we have the second line here, this line here, the second row of your data structure. With the IC at the beginning will be 0. So you get this number here, this 0 here. Then IC will be upgraded to 1, so you will get the second position, the number 0, and so on. And all this will be appended to the data structure. And then the data structure that you have at the end is just the same as you get before, this data structure here. And then you slice your data structure by using the slicing method, and you save your data in X and Y. So I can also write print here, print data to show you its structure here, and you have this result. So you have your data structure, which is generated by this nested for loop, and the X and the Y exactly as before. So a little bit more complicated than NumPy, definitely, but anyway, if you understand the logic, it's not difficult to work. Then generally, you don't only have to read files from your disk, but you also have to write files. Now, writing a file in the Python way, we're now using NumPy. So as before, you open your file. Now the file that I open is a file um, that must be opened in write mode. So I open a channel and I assign the flag W. So this channel is intended to be used for writing file, not just for reading file. The name of the file will be file from python.out and will be put in the data file folders. I have two lists, A and B, which contain this number. And now I use a for loop with on the two variables, IA and IB, and I use zip. I use zip here to put in together, join together the folder A, the list A and the list B. Then I assign values to this variable IS and EBS in this way. This list contain integer number, but to write data on a file by using the Python way, I cannot write numbers. I always have to write strings. So I have numbers, but I want to convert them in strings in order to be written in a file. So I take IS and IBS, which are nothing else as this number IA and IB. The first place will be 0516 and then 27, so on. And they will be converted to string by the str function of NumPy. So an IAS will contain the string 0, IBS will contain the string 5 at the first cycle. The second cycle, they contain the string 1, then the second one will contain the 6th string, and so on. Then I construct a global string. I sum the string by putting also the carry agent return and some space. So from IS and IBS, I will write for each line, so each cycle here in this for loop, I construct the ICS string, which is the concatenation, so the sum of strings, IIS plus spaces, the number of spaces that I want, plus IBS plus carry agent return. And I write this line, the string, on the line, on the file, line by line. Then I close the file. So let's see what happened. So the file I have to find in the folder is file from python.out. Okay, I have to start back. Data and files. So file from should be here. Okay, this is the result. So you see that I have this number. Now, in the external files, they are quite treated as number, but Python wrote them as they were string. 0, 5, 1, 6, 2, 7, so on. That was the result I wanted. Okay, so this is the way to write by using the Python way to write number on the file. Slightly different way that use a function which is write lines here on the in this construct. So I open my data files with this name with the writing flag. I have my two arrays, just the same as before, but then I write a list. So not a concatenation of element. I write a list stria, comma, so this is another element of the list, then strib, so I convert my number IA and IB in strings. I put also a carry agent return. So I do not write the string, a global string, but I write the list of strings. And this list of string is written on the file by using the write lines function. You take this list and write in the file. So the result is exactly the same as before. So exactly the same file here. Nothing different, just a little bit code in this different way. Now, there's an exercise for you. Uh, if we were in presence, the idea was to give you some problem, and then waiting for you could discuss how to solve the problem and um, make some proposal and write in the code to to get the result. So the point is merge a number n of data files, each containing a single column of data, which could be float numbers, and you want to merge of this single column of data in a single file containing n column. And the name of the files to be merged are written in some files in the folder. So I have a file name which is called filenames.txt, filenames.txt, and you see these file names contain 3 rows containing strings which are name of files. It is file 1, file 2, and file 3, dot. And this file must be also present in our folder. So file 1 contain this data, file 2 contain this other data, and file 3 contain this other data. So the idea is I have 3 separate files. I want one file only containing 3 columns. Each column should be the data which are retrieved from each file. Now, in the remote section, it's impossible. I can't. There's not. There's no meaning to give you some number to some time to do the exercise. But anyway, what I will do is give you some time to look at this code. It does exactly what I asked you in this, the text of the exercise. Let's say I will give 5 minutes, and you can make question, of course, and look at the code and try to interpret what is written here. So why I wrote the code in this way, and then after 5 minutes, I will come here and I will try to explain what I'm doing here. All the things I wrote here in this code are all things that we already seen before, so you should have all the instrument, the tools to understand. You see that in one case I used the Python code, my Python way to read a file, the file containing the names of files that should be merged. And in another case, for the data file containing the number, I use the numpy function load.txt. Okay, so I'll leave you some time here. So in 5 minutes, I'll be back. I remain here, but anyway, if you want to ask question now, you can do also. Can I use it? Okay, is anybody that understood the code and want to try to explain what I did here? Even in Italian?
Maybe I can try, I'm
All
not
right,
sure.
right.
So, first of all, we call NumPy and we say we are using NumPy.
Yeah,
And I think we are defining where to look for the file with
yeah,
this path. And then we open all the files that are in this path and are called file name.
all right.
Then in this file, in all of this file, we basically, if I understood correctly, read the lines until the lines are finished.
Yeah,
And then the file close. Then for each of these file, we want to print how many file we read and how they are called.
all
And these
right.
are these two print
Yeah,
instructions. Then, so now, if I understood correctly, now we read the files. Then we go, let's say, into the files. And for each of these file, that should be the I file, we look for the line. And in every line, we load the text that's that we find in the path and the file name. And we take all the text and then we separate the row and the column. So I don't know if this is correctly, because then there is the transpose, and I think it's the transpose is what actually
yeah,
put the numbers in the right order that we want.
yeah, yeah, yeah. And then everything is
And then
written.
we write
Okay,
it down in a new file.
everything is written with this format. Okay. Uh, so everything is correct. So I don't know if the other participant arrived to the same conclusion. Anyway, this data is initialized to empty array at the beginning. Then I will start a loop. I file in line, and line is the number of files that we have to read. And load.txt read the content of the file, but this is the numpy load.txt, so it read the contents number. They are no longer considered a string as Python does using the other method. So these numbers are written and written this call variable will be an numpy array, and then I update the data file, the data array that at the beginning was empty, by appending to it the column I read. So I see that what is the length of the data list, data array that I have. I divide the length by the number of files that I have in my data, so that I have the number of rows that I have to write in the file, the final file. So the number of columns will be simply the number of files that I have, and the number of rows will be the total number of data I have written in the data, in the array data, divided by the number of files. Then I transpose this in order to have a shape that we like, so a shape in columns, organized in columns, and I print yeah, on the terminal. I will write printed simple data, the number of data, and I save all on the this merged file dot out my data in with this format. Note that I use this format expression here. So the data will be written with a floating point format with two digits. And you see that I have a string, which is initiated by this apices here, some spaces, and then times, this star here, n file. So n files is also the number of columns that I have to write in the file. And so the strings, um, specifying the format, it repeated exactly the number of files I have. So exactly the number of columns I have to write. So I have, if I have 3 files, this will result in a total string containing percentage phi.2f, some spaces, and again percentage phi.2f, some spaces, and again percentage phi.2f. So all the data will be written in according to this format. I run the cell, and then I'll go here to the folder to see what happened. I should find a merged, it's here, the merged file out, and here's the result. So all the 3 files are merged in a single files. Very useful. You could do, of course, with Excel, but to do this with Excel, you have to open Excel, you have to copy the data from all your files that you have, and then to transfer the results in an export in another file. This is much. Of course, the first time is not very fast to do that, but if you have a function that do that every time, and you call this function every time you need to merge some file, that's a matter of seconds. So number of files to be retrieved, and these are the files. Okay, this is another exercise. By using Python function only, so no numpy, change the decimal separator of a floating point numbers in a file from the comma to the dot. Many, not always, but sometimes the numbers that you can read from data files, from download from internet, according to the convention, who wrote this file. Instead of having a dot to separate the decimal part of a number from the integer part, instead of a dot, sometimes they use a comma. For instance, in Italy, it's quite common, if you are not a scientist, 1.32, it is written as 1,32. We say 1, virgula something. No? So number can be written with a comma instead of a dot. And you have to, when you read this data, you want to use any elaboration system, you have to convert your comma in a dot. So there's some way to do that in a fast way possible. Yes, of course it is. You have, for instance, I write here number equal to a string with a comma, and I want to convert the same string, but by using a dot instead of a comma. So I write a number dot will be in the new string is number replace. So I use the method replace. So it is a function that will act on number and will exchange every comma I find in the file in the string here with a dot, and then I print results. So you see that I have the original number and the substituted one, the modified one, which has a dot. Of course, well, when you this should be done always if you have number containing comma instead of dot, because imagine that you want to convert your string in floating point numbers to be used in the Python system. You have to convert the string to float numbers. You are using the float function. So I run the cell, I print number dot, which is type number dot, which is of class string. So number dot is a string. The thing that you see here is a string. But then I convert the string in a float point number by using the float function. And I print now the float number, its type, and the number itself. So type of float number is class float, so it is being converted, and the number is this one. So the float number representation of this string here. But you cannot do that for number, which is not number dot, is the number is 15, 97, and so on. So if you try to do that, you get an error because you cannot convert the string to float because there is a comma here. Okay, here is another exercise where you have files containing commas, the files as commas dat, so we search it here, commas dat. And you see that you have two columns and your numbers are written with commas, not with dots. And you want to convert this file in a file that contains only numbers, proper numbers containing the dots. So look for dots that. This is the same file, but with the number which are being written properly by using the dots and not the comma. So this is the comma and this is the dot, you see. Okay, so this is done by using only Python functions, not NumPy. So I start to read the file input. My file input file will be data files and commas dot, and the file out will be written out is the data files dots point dot. I open the input file, so I assign it to a channel. I create a channel F. And I start by writing a line which is a list empty list. I set flag equal to true. Then I start a while loop on flag. It will go on reading lines one by one from my file until it reaches the end. And when the end is reached, flag will be set to false. Otherwise, when the line is not empty, the file line which contains the line of the file will be appended to the line list. So at the end, we will get our line list. Then I close the file. Then I create a new list from the original list. In this way, I use a list comprehension. I could also write here not list parentheses. I could also use the square bracket in order to have directly the list and not the list generator. The same thing. Okay. So I use list comprehension on each line of the list line for each SD in line. So the variable SD will assume every value in the line that we read from the line list. And for each line, replace the comma with a dot. And the result will be put in this list, which is called new list. Then I open my file out, use this name, dot that, as with a flag W. So this is a file intended to be written. And for each line, for each line in new list, for each element in this new list, write the line, appending also a carriage return, then close the file. So I run this one, okay, got any error, and so I look at dot that, and this is the result. So very, very common operation to do when you have numbers containing comma and you want to change commas with the dots. Okay, this is the same operation I wrote. Oh, okay, here I use a context manager, but I think now I will skip this cell. I use another keyword. It is called a context manager. We will return this subject, the context manager, later in some other later lecture when we are defining classes, because it's not that it's not that important, but is frequently used. So if you read programs written by others, working with files, you very often find with this with construct, but we will explain. I will explain that at a later time. Okay, so now I switch to another notebook. Very important notebook now is the notebook dealing with functions. And okay, I return here on the factorial computation that we compute this morning. Now, we see several things till now. We have seen assignment, so variables, type of variable, list, so on. We saw conditionals, operation, loops, and we also saw how it is possible to work with files. Not anything that can be possibly done with files, but the most important things. Now another subject that is very useful when you work with code, you always use function. So come back to the factorial that we computed this morning using this cell. This morning I used this while loop in order to be able to compute the factorial of a number. And imagine that you have to do that several ways and in several files, in several programs, you always have to do with factorials. And every time you should write a construct like this one in order to be able to compute the factorial. And also this factorial, this loop and this procedure is being computed by using an equal to 6. And if I want to compute the factorial of another number, I have to come to the code, change the number n in, and again rerun this cell. That's no good. So what you can do is to use a function to do that. So you can construct a list of structure which are enclosed under the def, which is now we will see what is def. Anyway, under some object which is called a function, which has an argument, and every time you have to compute the factorial, you simply have to call the function. So what is a function? How it is defined? First of all, you have a keyword def. Every function always starts with a keyword which is called def. Then you define the name of the function you want. I want to compute the factorial, so a reasonable name for the function is just factorial. No, don't call it f or something like that, short name, because otherwise in a later time, maybe the day after or the month after, you will not know by reading the code that is a function to compute the factorial. So use a name for function which is remind you of what this function is doing. Then you have parentheses. You have always have parentheses following the name of the function, and inside the parentheses can be present several objects, maybe nothing, or as in this case, a number, a variable, now a variable n. Then you have a colon, and following exactly indentation, doesn't matter with a column where you start to indent your code, but once you have chosen your indentation, you must be followed that indentation up to the end of the function. So you have a number of structure here under the factorial function, which are exactly the instruction that we've used this morning. Just I eliminate the print message here, but otherwise they are the same in structure. So I initialize a variable jn, I initialize a variable fact, then I open a loop for jn less or equal to n, where n is the argument. This is called also the argument of the function. So a variable that will be passed through the body of the function. Oh, by the way, all these functions here are called the body of the function. So this argument end of the function will be passed to the body of the function, and it is used here to control this while loop. This jn variable, as you can see in the last instruction here of this while loop, is upgraded every time. This jn equal to jn plus 1. So at some moment, jn will be greater than n, and then will be stopped. The while loop will be stopped. And until jn is lower or equal to n, fact variable is upgraded by writing fact times jn. Fact is initialized to 1, then you have all the product, all the number up to n, and the result is stored in fact. Then you have a return facts. This function produces a number, produces a factorial, and you want that number, that's the factorial, the number, to be returned by the function. You want run the function, and you want result back. If you don't write return fact, the function will work, will make its computation, but you will not see nothing. You will not see the results. So that could be an unuseful function. In this case, instead I put a return. You look at the indentation. Return is indented as every other instruction in the body. The indentation here is indentation under the while loop. This is indented as the while loop and all the other rows of the body of the function. So the function will end and will return the number fact. So I can I have to clear the output of my notebook. Now I run it. Okay, nothing happened because I defined the function but did not use it. I just defined a function that could make the computation, the factorial, but in order to compute the factorial of some number, I have to call the function. So I can write factorial 5, for instance. So the number 5 will be substituted to the argument n of the function. And you see, I don't need to prefix anything to the function name, just compute the factorial number 5, writing factorial 5. So I can do that. Okay. 120. If I want to compute the factorial of the number 100, no problem. I run here my cell here, and so I will call the factorial function with the number 100, which is a very large number. Of course, you can use a little bit smaller number, and you get this number here. Okay. Now, you can also use this factorial function in more elaborate construct. For instance, here I have a list of numbers, 1, 2, 3, 4, 5, up to 7, and I want to compute the factorial of all this number and print out the results. So I will use apart this print n and factorial, we just will print an n and an f factorial, and we'll go on a new line, /n. Then I will start a loop for il in n list. So for all the numbers contained in this n list, print il and the factorial of il. So I run it, and I got this result. This is n factorial. This is what is being written by this print here. And then print il factorial il. So the factorial function is called for each il, and the result will be printed. Now, a first hint that on a subject that will be considered later, maybe tomorrow, which is always raise an origin of confusions for students or from people that start to learn to using a program like a system like Python or other language. you see that I defined the variable fact inside my factorial function. I even called the number of times the factorial function. And now maybe I want to have a look at the number fact that was defined in my factorial function. The variable fact has been defined inside the function, and I want to look at what is its value at some point. So I can see, all right, print fact, run, and you see what is the result. Name fact is not defined. So the variable fact was created inside the function, but then, and the function was called, but when the function is finished its work, even if I return the fact variable, if I return a number, the variable is lost. So it is no longer present in my so-called namespace. I will return this terminology, what is a namespace. I will return on it in a later lecture. But that's the result. So the fact variable is lost. If I want to recover the number, the fact variable, in fact, I have to assign the return, the result of the factorial function to a number, or to a variable, which I can call fact, or I can call in any other way I want, not necessarily fact. And then I can print fact. So I call the factorial function. The factorial function return a number which is stored in the variable fact. So this number, not the name of the variable, but this number fact is saved in the variable fact which exists in the global namespace, so outside the function. And if I print this fact that I print here is not the fact that was defined in the function, but the fact which is defined outside the function by using this operation here, using this instruction here. And the result is 540. Okay, don't worry if you don't understand now the point, because it will be I will dedicate a whole lecture in later, maybe tomorrow. Anyway, the point that I want to emphasize here is that we can group a number of structure under this construct, which is a function defined by the def keyword, and that may be possibly, no, does not always, may possibly return some value, one or more values. Now, keyword arguments. I defined this factorial function above in the way you see, but maybe that we want this function to return the number, the factorial computed, just as a number without any other specification, or we want a more extensive printing, a more extensive message from the function. And so there could be a message which is print the factorial of the number that I gave in input, as is n here, is and the result. So I use this printing function. You see you have a string containing this. I discussed this yesterday, containing this %3i and %6i. Then this string is closed, then you have a percentage symbol, and then you have a tuple containing the value n and fact inside the function. So both these numbers are defined inside the function. And when the print instruction is executed, the number n that you find here will be substituted to this %3e and printed as an integer by using 3 digits. And the number fact is substituted on this %6i, so the number will be printed using 6 digits. But I want that this printing to be not the default. So generally, I want to use this factorial function as a function that simply returns a number. Sometimes I want that the print message will be printed explicitly, so this message will be printed explicitly. In that case, I don't want any number returned by the function. What I want is just this message and nothing else. So I use this construct in the argument list. N is the mandatory argument, must be always present. This other argument is a keyword argument, and it is optional. And I foresee here option, a default choice for this keyword argument. PRN will be the argument, and it is set as default at the value false. So I can call the factorial function by using n and nothing else, and the function will assume that the PRN keyword will have the value false. Or I can write explicitly n, comma, PRN equal false, or otherwise I can call PRN equal true. In this case, this PRN will be equal true, and this PRN is used in this conditional evaluation. So if PRN is true, then print the message and exit, nothing else is done. If PRN is false, don't print this message, but else return fact, return the number. So I redefine the function here, and then I call the function factorial 5 with PRN equal true, and you see that I got the message. The factorial of the number 5 is 120. If I call the function without specifying any keyword, not PRN equal true, but just factorial 5, I got 120, so the return fact is executed, and it's the same result that I would get if I specify PRN explicitly to false. I will get the same result. So this is a keyword argument. Keyword arguments are very useful because many times you have functions that you write function that can accept just a lot of number of arguments. There are some thumb rules that says that the argument that you should pass to a function should be no more than 4 or 5 at most, but in many cases you can have function accepting a very large number of parameters, but you don't want to every time to specify each of these parameters because you may have defaults which are good enough for many occasions, and so you write this parameter in the form of a keyword argument. And this is just one simple example. Okay, I will say you something later concerning the argument. The subject is not finished here. Then something else, very important, documenting the function. You should always, of course, if you are doing just some test or a very, very small exercise, and so you write simple function that have no use in your work, you can omit this passage. But otherwise, if you write programs that can contain underdot functions, document your function always. So write some string, now we show you how to do that explain what the function does and what's the meaning of the argument, what's the default of the keyword argument, and what the function returns, and if you have some note explaining some in which you can put some additional information. So the way you write a documentation is this one. There are many ways to write documentation. Anyway, this one. You start with this 3 character on, these 3 apices at the beginning. That will be closed at the end of this comment or the help of the documentation. That's called just documentation. And here is the text. Compute the factorial of a number. This is what the factorial function does. the arguments that the factorial function accepts. It accepts a number whose factorial has to be computed. There are keyword arguments, so you write keyword arguments and k args column, then you go and the new line, it will print prn column. If true, so if this variable is true, result is printed and default is false. What the function returns, so you write returns factorial of number n and a note. I wrote also the note, if prn is true, no value will be returned by the function. You see here the function, if prn is true, does not execute return fact, so no number will be returned by the function. What's the use of this documentation? Well, imagine that you have written a program. This program contains you have written a module, so the program is called module. This module contains the function factorial. You import your module in another module, import. So you takes all the content of the module and import it in your system, in your environment. So the function factorial will be imported, but you don't see the factorial function explicitly. You just have the definition of the factorial, but you don't see the code, and you don't remember how to use it. So you can write L factorial, and you see that the function L, which is built-in function of Python, will print out all the documentation that you have wrote for the for the function. This L factorial, of course, works for any command of Python command or NumPy command. So if you want to get L for your functions or function written by others, peoples, or built-in function of Python and so on, you can always use L. L factorial, in this case, will provide you the strings, this documentation. Another way to get help immediately, for instance, there is a function which is called factorial. So you can start right to factorial. Then you open the parentheses for writing the argument, but instead of writing argument, you press at the same time Shift and Tab. If you press inside the parentheses Shift and Tab, you open a window, and if you click on this window here, you have your documentation. So everything which was written by the help function is used. This is happening in the Jupyter Notebook. This is a functionality feature of the Jupyter Notebook, and so you can have your help system is very, very, very useful. I want to cut this out. So, okay. I wrote the documentation in this way by using a specific syntax. This is not a syntax, this is a random syntax, args, comma, args, colon, and column indent in some way, because that's a good way to read documentation. And now I show you something. QM thermodynamics. Read the docs. Okay. Why don't see here? Okay. Okay. I'm working since a couple of years with a project compute statistical thermodynamics on quantum mechanical data for minerals. And there is a system in Python, in the Python ecosystem, exists a package which is called Sphinx, Sphinx like the Egyptian Sphinx, that help you to write documentations. Take into account that if you write a program that you pretend that other people will use in the future, if you don't have documentation for your program, the people will never use it. And you yourself will have the difficulties. If the program is complex enough, you will have difficulties in using the program at much later time. For instance, you write the program this year, and next year you will want to use it again. And if you don't written any documentation, it will be very hard for you to use it. So write always documentation. And what I want to show here is this index here. Okay, you see that I have a long list. This is all produced by this package, which is called Things, automatically, provided that you wrote your documentation the way that I show you now in this way. So if you use a method to write in documentation this way, you can use Sphinx, and Sphinx will produce an output like this one. You have a list all the functions that I have defined in my programs. There are many functions. If you go to each of this one, okay, for instance, this one, the help, the documentation is formatted in this way. So all all that you wrote in the wrote under the args keyword will be transformed in this way, will be formatted in this way. We will have parameters, and then the name of the parameters written in bold, followed prefixed by this dot, so you can. It's very easy to read it. And you have the notes. These are highlighted in this way. So it's better to have your documentation written in this way, because in the later time you can compile it and load it in some websites that, in this case, is Read the Docs, that help you to understand what you have written in your program. And another very useful facility is that you have, for instance, this alpha-dir function, the name of the function, with all of the arguments that can be passed to this function. You have the explanation of the argument, you have the notes, but if you click on source here, you go directly to the source of the function. And you see that I wrote here the documentation exactly as in the way I showed you before, and here is the function. So you can go directly to the function and analyze the code and understand quickly what this function does and how it does. At least you can understand easily what the argument the function requires. So it is important to write documentation. This first rule of information technology people is always document your code. Otherwise, the code will be unuseful in a few weeks, even by yourself. If you don't document your functions, if they are could be complicated. If you don't document your function, we will not be able in the future to use them anymore. Okay, now if I have still 10 minutes, or if you have questions, of course, make questions. I will go through a few other lines fast, because the argument is not very simple at the beginner level. But there is this idea of recursion that is specific of some language, not of all the language. For instance, Fortran has no recursion. C, I don't know if C has recursion. Lisp has recursion. Python has recursion, but not all of the possible programming language have recursion. Recursion means that a function can call itself. For instance, here I have a very simple function I call recursive n that just prints a number n, the number n as I put in as I use as an argument of the function. Then n is decreased by 1, and if n is greater than 0, then the function is again called with a new argument n. Now, n at the beginning was the number you gave. Imagine that you use for n, use the number 5. So it will print the number 5, then it will decrease the number 5 to 4, n minus 1 is 4. It is assigned to n. N is greater than 0. And so what is the test is true. And what is done here is to call again the same function, recursive, with the argument 4. So it will print 4, will decrease n again to 3, and so on until n becomes 0. In that case, the function stops. You will see here what happened. I define the function, and I write recursive. I can write a larger number, like maybe 10. That's the results. All the number between 10, 9, 8 till 0. So this is done with this recursive method. Okay, so it is easy to be understood. It's not very difficult. The function that calls itself a little bit strange, but anyway, the example should be clear. What is difficult is not to understand a simple example, but it is difficult to write some less trivial computation using recursion. I will show you an example in some lecture later of recursion. Here I wrote an example, but I decide now, this morning I look at it and decide to skip it because it's not very simple. It is not difficult, but I already introduced here the concept of class. That is, will be we will work with class in a later lecture, so now you'll not understand much of this example. But this thanks is that I use the recursivity to compute the factorial of a number. So I use this object, which is factorial class. I define an initial number which is set equal to 1. Then I define a factorial function, and this factorial function will call factorial rec function, and the factorial rec function is the function which is recursive. So you see that factorial rec function call itself. So this is an example of recursivity. Then I define here an instance of this factorial class, and I call this instance ff, and then I use it. So I run the cell, I define here this class, I define here this instance of the class, and then I can write this. ff.factorial, now this factorial function becomes a method of the ff object, which is an instance of the factorial class. So this is a method, ff dot. 8 as an argument, pr equal to true, so I got in back the message. The factorial 8 is this number, 40,320. The same results can be obtained, of course, with the original factorial function, which I defined before. I can test the time it takes to execute. I have a function here, which is a time it, that takes as an argument a function with an argument. I want to compute the factorial of 500. And if I run it, it takes some time, not because the computation of the factorial takes so much time, but because in order to have an accurate measure of the time a function takes to perform a task, the function itself is repeated a number of times. So in 7 runs of 10,000 loop each. So I compute the factorial function of 500 number for 7,000 times, in this case. 7 runs divided in 7 times in 10,000 loops. And the results divided by the time it takes divided by this 70,000 number that the function was run result in 87 doxic microseconds with an error of 1.4 about microsecond per loop. So the time it takes to compute the factorial of 500 is about 87 microseconds by using the original factorial function. Is there any advantage of using the recursive version of this factorial by using this class methods and so on? Well, we'll see. We time this other function here. And after some time, hopefully not that much time. Okay, it takes longer. It's about twice slower because it takes about 200 microseconds. So it's better to use this factorial as I defined before, as not the recursive version. This is just done for demonstration purpose, just to see how it works. Another way we will see another way to compute the factorial of a number by using recursion and without using classes. How will we see next time? Then there are something else, but we'll go through this tomorrow. Function can return more than one number, more than one result. For instance, I have a function here taking 2 arguments and the result making the multiplication of the 2, c equal to 8 times b, and then returns c, but also a, b, and c. And I can store all the 3 value which are being computed by my function in the variable v1, v2, and v3 by using this syntax with a comma. So I got 3 numbers in output from the function that are stored at the same time as 3 variables, and then the 3 variables are printed. Or maybe I'm not interested at all in the variable ab. After all, they are the argument of the function, and I don't want them back. But anyway, the function will return 3 numbers. So what to do? I can write the string syntax. I use the underscore, comma, v3. And so the first 2 numbers, a and b, will be forgot. They are lost in the system, and v3 is only saved, and the print is obtained. Okay, now I can write in this other way. Well, all the 3 returning of the function, all the 3 numbers are packed together in a list, not in a list taken but in a tuple. And so I can also write VL equal to my function 5 for 5 and print VL. So VL is this var is this tuple which has been saved, and the result is this one. Okay, questions? No questions? Okay, if there are no questions, then we'll restart again tomorrow morning. Goodbye.
Bye-bye.
Thank you very much. Bye-bye.
Thank you. Bye.
Bye.